Hello and welcome to a new lecture in which we're going to learn about two important concepts, the concept of equivalent systems as well as the principle of moments. So if we consider two systems, which can be a rigid body or a structure or something similar, in order to have these systems equivalent, so meaning behave in absolutely the same way, we have to establish two important fundamental conditions. The first condition is that the sum of all forces on the system A must be equal to the sum of all forces on system B. So the resultant of all forces must be equal on both systems. In a similar fashion, the sum of the moments about a point O on system A must be equal to the sum of the moments about the same point O on system B. So this is very important to remember. The point about which the moments are summed are the same. So if these two conditions are satisfied, then the two systems are equivalent. And this is a very important concept that we were going to use throughout the course. Very, very fundamental concept. Now, once we have established when two systems are equivalent, we're going to learn about the principle of moments. Principle of moments, which is also known as the Varignon's theorem. So this principle states that the moment of a force about a point is equal to the sum of the moments of the components of that force about the point about which we sum the moment. So this is a very important principle because often, as we will see, it's easier to actually determine the moments of the components rather than the moment of the original force, and then sum the moments of the components together in order to obtain the total moment of the force. So I'm going to illustrate this principle by a simple example. And in this example, we have a bracket, a C-shaped bracket, which is laid on the ground as I'm drawing it right now. So you can see the bracket, the C-shaped bracket. And now the bracket is attached to the ground at point O, and point O is, as you will see, located at 60 millimeters away from the left edge of the bracket. The height of the bracket is 120 millimeters, and the horizontal width of the bracket is 100 millimeters wide. Now, there is a force acting at point A on the bracket, and the force has a magnitude of 400 newtons and is directed 60 degrees clockwise from the vertical. You are required in this question to determine the moment of this force about point O. So, in order to do that, for a simple question in two dimensions, we have to multiply the magnitude of the force with the moment arm, d, which is the perpendicular distance from O to the line of action of the force. Now, if you look at the diagram carefully, you will notice that the calculation of d is not that straightforward. It's not easy to obtain the value for D. So therefore, what we can do is resolve the force into its x and y components. So as you can see, I've drawn the parallelogram at A, and this is Fx and Fy, the two components of F. And now, based on the principle of moments, we can actually calculate the moment of Fx about point O, and we're going to call this M1. So 400 newtons times cos 30 degrees gives you the magnitude of Fx, and now the moment arm for Fx, the distance from Fx to point O, is 120 millimeters, as you can see in purple. So this moment equals to 41.6 Newton meters. You can see that Fx rotates around point O clockwise. If you, for example, imagine a wheel centered at O, Fx will turn that wheel clockwise. So that moment is hence negative. Now, secondly, the moment produced by the y component of F equals to 400 newtons times cos 60 times the moment arm of Fy, the distance from O to the line of action of Fy, which is 40 millimeters. And that gives us 8 Newton meters. Fy would rotate around O counterclockwise, so this moment would have a positive sign, would be positive. Now, based on the principle of moments, all we have to do now is sum the moments of the components of F, and that would give us negative 33.6 Newton meters, or 33.6 Newton meters rotating clockwise, and this would be the final answer, the moment of F about point O. So we've learned two very important principles, the principle of equivalency and the principle of moment. So please remember these principles, and thank you very much for watching this lecture, and I'll see you at the next one.